As always, with the last 24 hours on our star, once again, there were no significant solar flares. The next short cycle uptick is expected later this month and into November. However, we have been expecting an impact in the solar wind from the coronal hole stream, and it is happening this morning. This is the telemetry from the Discover satellite, and we'll begin up top. The amplification of the red and black lines indicates the impact of the more intense solar wind is arriving. It began with the flip in the solar wind magnetic field, which you see in the blue panel below that, and in the two panels below that, you see the slight rise in the last few hours in plasma density and speed, the orange and purple. That is the leading edge of the coronal hole stream. Over the day today, the density should drop out slightly while the plasma speed and plasma temperature, the bottom panel in green, begin to rise even more. When that happens, we should begin to see increased geomagnetic activity. It is likely to be minor, but could spark auroral activity around the poles. Otherwise, we are still keeping an eye on the sunspots in the plasma filaments. There remain several potential eruption zones on our star, and we already saw one plasma filament release, doing so off the northern reach and producing a CME that is headed due north and will not impact the Earth. Next, we've got a study on astronaut safety, and based on historical solar activity, they have determined that deep space and lunar missions may be exceptionally risky due to solar energy damage to the central nervous system. They say Mars missions are less risky, which may not be true for the biggest events, and which certainly isn't true for the trip there and back. And as Earth's magnetic field is weakening and providing our planet with less protection from the sun, it also has implications for the central nervous systems of people here on Earth. Last but not least, a preprint under review for publication detailing the impact of space weather to the low-latitude ionosphere. It wasn't that long ago that scientists believed that solar storms almost exclusively impacted the polar region. They now know that through the direct magnetospheric compression, the particles are forced downward onto that low-latitude layer, and when the polar region is affected, the energy is transferred towards the equator through the ionosphere as well. These are key concepts for how the global ionosphere is impacted during solar storms, which also